Okay, Assalamualaikum and hello. Okay, today I would like to share about one of the topics that is covered in lecture 3. This slide can be obtained from my Moodle page. So the topic that I'm going to share today is about buoyancy. So as you can see in the slide, the definition of a buoyant force is given as the vertical force on a body immersed in a stationary fluid. Okay. So if you want to know the example of buoyant force is when you want to dive into a swimming pool, it can be hard or frustrating because the water tries to push you back to the surface. So this upward force exerted by water on you is called as buoyant force. Okay, so why do fluid exert an upward buoyant force on a submerged or an immersed body? The answer is it has to do with the differences in pressure between the bottom of the submerged body and the top. Okay, so if I can show you, for example, you have a body that has a cylindrical shape. Sorry. So this body is immersed or submerged in a stationary fluid. Therefore, at the top and at the bottom of the body, there will be pressure exerted. But these pressures are different because as you go deeper, the pressure will increase. So you should have a greater pressure here as compared to here. Okay. So how do you measure the buoyant force? Okay. By the way, this buoyant force, yeah, it can be obtained by using the difference in the pressure force exerted at the top minus the bottom. So since the bottom part has greater pressure, so it has greater force. Therefore, this buoyant force should act upwards. So it has more at the bottom compared to the top. So force can be obtained by using pressure times area. Okay, substitute into the equation. And pressure can also be measured by using rho GH, where rho is the density of the fluid, G is the gravitational acceleration, while H is the height. Okay, so since it's the same cylinder, so the cross-sectional area should be the same. So rho and G are of course constant. Therefore, these three are constants, while H should be the difference in the height. So the difference in the height is here. So by the way, area is a cross-sectional area. You times with the height, you should get a volume. Okay, so which volume you want to take? So if you see here, you should take the volume of the object, right? However, if you notice, when this object is, or the body is immersed or submerged in a fluid, so the fluid will be displaced, okay, by this object or body. So the space is now occupied by the object or the body. So, however, these two volumes, the volume of the body or the object and the volume of the displaced fluid could be different if if the body is partially submerged or immersed in the fluid. Therefore, in this case, you cannot take the volume of the object, but you can just take the volume of the displaced fluid. Therefore, I put this as the displaced fluid. So rho, you times V, you should get mass, since rho is equals to mass divided by volume. So rho times V is mass. So I replace this with mass of the fluid times G. Mass times G is weight of the displaced fluid. So this equation, if stated in words, it's called as Archimedes principle, where the buoyant force on an object or a body is equal to the weight of the fluid displaced by the object or the body. So we go back to the slide. This buoyant force acts through the centroid of the displaced volume, and this centroid of the displaced volume is called as center of buoyancy. Okay, so let's move on to the example. So a metal part is hanged by a thin cord from a floating wood block. So this is the metal, this is the wood block, and the wood block has a specific gravity of 0.3 and dimension 50 times 50 times 10 millimeters cube. You have to convert this to meter cube. The metal part has a volume of 6,600 millimeter cube. So convert this to meter cube. So find the mass of the metal part and the tension in the cord. Okay, so let me do this. Copy. So this one I will make it clear. I copy. So I put this here. Okay, make it bigger. Should be bigger. Okay, should be okay, right? Okay. So write down all the information given. It's given that the SG of the wood, so I put it as 1, is 0.3. The volume of the wood is 50 times 50 times 10. So we need to convert this to meter cube times with 10 power of negative 9. The volume of the metal also has to be converted to meter cube. Alright. Now, so let's do this. So before that, I think it's better that you draw a free body diagram. So for FBD1, I just draw it here. FBD1, the weight should go down. Sorry, FBD2. This is FBD2. So it's better I put 1 first. Going down is the weight times tension, and going up is the buoyant force. Okay, and this one I think I better change to different color. Red. Going up is the buoyant force 2 plus tension, and going down is the weight. Okay, so let me settle number 1 first. Taking the summation of force in y direction to be 0. So FB1 minus weight minus tension, you should get a 0. Therefore, which one you want to take? You want to measure? It's a tension. This one you can measure, this one you can measure. So you rearrange this so that you get tension equals to FB1 minus weight. Okay. So is the wood fully submerged or partially submerged in the water? No, right? Only 10 minus 2.5 millimeters, so it's 7.5 millimeters height only. Therefore, when you want to find the buoyant force, just take the height, mm, 7.5 only, not the full height. Okay, so since it's rho g volume, you can also use gamma if you want, because gamma equals to rho g. So I just use gamma. Gamma of water times with the volume of the displaced fluid minus, so weight can be obtained by using gamma also, but this gamma is the gamma of the wood. Okay, this is the fluid, this is the body. So the weight is for the whole body. So gamma 1 times with the full volume of the body. Alright, so gamma of water at 15 degrees C is, if you check in table 1.3, it's 9800 times with volume of the fluid displaced fluid is 50 times 50 times 7.5 only, times with 10 power of negative 9 minus with gamma. So how do you get gamma of the wood? Sg of the wood times gamma of water. So Sg of the wood, I think I should write it at different place. So Sg of the wood, Sg is equal to, sorry, to get the gamma of the wood, Sg of the wood times gamma of water. So Sg is 0.3 times with 9800, and you times with the full volume of the wood, which is 50 times 50 times 10, and then times with 10 power of negative 9. So what do you get? Let me calculate it first. I didn't calculate it before. So 9800 times 50 times 50 times 7.5 times 10 power of negative 9 minus 0.3 times 9800 times 50 times 50 times 10 power of negative 9. So the tension is 0.11 Newton. Okay. Okay. All right. So once you get this, you do for the red one. So the red one, I use red color lah. Summation of force in y direction is equal to 0. Therefore, FB2 plus tension is minus weight So this weight, instead of using weight, you can also write it directly as mass times g, because you want to find m is equal to 0. So rearranging, mass is equal to fp2 plus t divided by g. So by the way, fp2 is gamma of mm, the displaced fluid, which is water, times the full all the volume. Okay, the volume of the metal is fully submerged. You plus with the tension that you get previously. So we try to replace this. I will try to calculate it. 9800 we times with 6600 times 10 power of negative 9 plus tension that you get is 0.11, you divide by 9.81. So the answer that you should get is 0.0178 kilogram. So if you convert it to gram, it's 1, 2, 3, it's about 17.8 gram. So this should be the answer for this, and this should be the answer for the tension. Okay, so I hope you guys can understand this topic. If you have any question, you can just email to me, or you can just comment in the slide, sorry, in the video. Thank you.